Well, hello everybody. In this video, we're going to move on to another section now where I'm going to show you how to name and write formulas for molecular compounds. Ooh, molecular compounds. Well, that's very different. Everything in my last few videos has surrounded the names and formulas for ionic compounds. But now we're going to move on to new territory, molecular compounds. So the first big question is, well, what the heck are molecular compounds? They're compounds that are made of nonmetals and or metalloids. In molecular compound formulas, you will not see a single metal atom. The minute you see a metal atom in a formula or the name of a compound, that you then know you're looking at an ionic compound. But for this video and for this section, we're only going to look at molecular compounds, so you will only see compounds made of nonmetals most of the time. And then sometimes there will be a metalloid stuck in there. Here are several examples of molecular compounds. Two of them are very familiar to you, good old carbon dioxide and water. But if you look across at all these other compounds, you'll see that there's not one single metal in sight. This molecular compound has got a rather large formula. This is the formula for caffeine, something I rely on a daily basis. We will not learn the naming system for very large molecular compounds such as this one, so forget about that. I'm not trying to scare you with this one. We're going to concentrate on what they call binary molecular compounds. What makes the rest of these are binary molecular compounds. What makes them binary is the fact that they're made up of exactly two different elements. If you take a look at each of those that are put in the green dots nearby, they're each made up of two elements exactly. All right, then. So what sort of rules will apply to the naming and writing formulas of molecular compounds? Well, so far, with regard to ionic compounds, here's a lot of the rules and techniques that we've used, right? We had to use the crisscross method to figure out what the subscripts were. In order to do that, we had to figure out ionic charges. And the ionic charges involved a lot of work with our good friend, the periodic table, and sometimes the table of multivalent metals. We often had to remember to put subscripts in lowest terms after crisscrossing them. Then Roman numerals got involved. When do you do those? When do you not use those? Sometimes parentheses were important, particularly when polyatomic ions got in the picture. And then, yeah, like I said a moment ago, multivalent metals were part of the whole scene. So which of these rules here apply to the molecular compounds? I have great news. None of them. That's right. Almost everything you learned about ionic compound names and formulas do not apply. So you can forget about all those for now. What does apply? What are the rules? Well, when it comes to naming and writing formulas for molecules, there is what I like to call the prefix system. The prefix system includes a series of numerical prefixes which describe how many atoms of each element a molecule or a molecular compound is made of. And here, ladies and gentlemen, are the 10 prefixes that are going to be crucial for this thing here. Most of them are familiar to you. Some of them might be new and a little bit weird. You can write these down for yourself somewhere. It is a good idea to commit them to memory. And I think with good practice and experience, you probably will commit them to memory. That's it for now. Please look at the second video about molecular compounds to show you how to use these prefixes. I say to all hand, that means have a nice day.